Question number 2.29. A gaseous hydrogen contained initially under standard condition in a sealed vessel of volume 5.0 liter. Okay, so it is at standard condition. Okay, now if this is cooled at delta T is cooled by 55 kelvins. Okay, so find the how much internal energy of gas will change and what amount of heat will be lost to the gas, right? So initial state is given when temperature is 273 kelvins and volume is given, okay, and it is being cooled by 55 degree Kelvin. So first let's try to calculate how much heat will be lost by the gas. Okay, so look, in this case the vessel is closed. Okay, it is sealed properly. It means there would be no change in volume, right? So if there is no change in volume, so we can use a specific heat capacity, okay, for at constant volume. So heat lost by the gas is equals to NCV delta T, right? And it is a gaseous hydrogen, so this CV would be equals to degree of freedom divided by 2 into R. Okay, and for diatomic gas it is 5, so we can replace CV by 5 by 2 R. Okay, and here we are taking 1 mole, so this is delta Q is equals to 5 by 2 R, or let's take N into R into delta T. Okay, so this delta Q is equals to 5 by 2 into N into R. This is being cooled, so we can take minus 55 degree. Okay, it's not a big deal. This is minus 55 kelvins. Now, this term we want to remove as we don't have information about its number of moles. Okay, so we can use a standard gas equation. Okay, that is ideal gas equation PV naught is equals to NR T naught. Okay, so it means NR would be equals to PV naught upon T naught. This is standard condition, so here you can also take T naught is equals to 1.103 into 10 to the power 5. Okay, so we can replace this NR. So from there we'll get delta Q is equals to 5 by 2 into PV naught upon T naught into minus 55. Okay, so from here we can calculate heat lost by this system, that is 5 by 2 into 1.103 into 10 to the power 5 into 5 liters. So 5 into 10 to the power minus 6 meter cube. We are taking SI units. And this is divided by 273 into minus 55. Okay, so from here I will calculate this, then we'll get Q equals to minus 0.025, and if I'm not wrong, then it is in joules. Okay. Look, so here we have got that how much heat is being lost from the gas. But the question is asking that what is the change in internal energy of this gas, right? So basically this is, we are getting in kilojoules, okay, not in joules. Now change in internal energy. So for that we have to apply first law of thermodynamics. Okay. So if we apply first law of thermodynamics, that is delta Q is equals to delta U plus delta W. Okay. But in this process, this vessel is properly sealed, so there will be no change in volume. Okay, so it's an isochoric process, and the work done is P into delta V, which is equals to 0. It means change in internal energy would be equals to heat lost by this system. So delta U also be equals to 0.25 kilojoules. Okay.